Welcome back, students. Today we'll be solving a few problems on the topic that we have learned in a previous class, that is rounding off numbers, significant figures and arithmetical operations. We will be shortly revisiting the learned topics so that it becomes convenient for us to apply this knowledge in solving the problems. We have already studied about the rules to find the significant figures. As you can see, it is right now coming on your screen, so you are very well aware these were the rules that we are taking into consideration while finding out the significant figures. Now any result is calculated by compounding two or more variables which might have been measured with different degrees of accuracy. Inaccuracy in measurement of any one variable affects the accuracy of the final result. Hence, in general, the final result of compounding any number of variables shall have significant figures corresponding to their number in the least accurate variable involved. To understand this, I would give you the example of a chain of which all links are strong except the one. The chain will obviously break at the weakest link. Thus, the strength of the chain cannot be more than the strength of the weakest link in the chain. Therefore, the results of arithmetical operations performed with measurements cannot be more accurate than the original measurements themselves. Hence, we ensure that we do not imply a greater accuracy in our result than was obtained originally in our measurements. So, for multiplication or division of numbers. In multiplication and division, the number of significant figures in the product or in the quotient is the same as the smallest number of significant figures in any of the factors. I repeat once again, in multiplication and division, the number of significant figures is in the product or in the quotient is the same as the smallest number of significant figures in any of the factors. For example, if x is equal to 3.8 and y is equal to 0.125, then x into y will be equal to 3.8 multiplied by 0.125, that will be equal to 0.475. As least number of significant figure is 2, that was in x. In x, as you can see, there are only two significant figures. So we have to keep in mind that in the result, that is in the product xy also, the number of significant figures should be equal to 2, and so this result is rounded off to 0.48. Again, suppose we have to write the quotient to correct number of significant figures. Let us take one more example. We have to write down the quotient. Suppose we have to find out the quotient 9500 divided by 10.23. So that will give us 928.64125. This will be the result. As 9500 has minimum number of significant figures. 9500 has minimum number of significant figures, that is 2. Therefore, the quotient can have only two significant figures. So, on rounding off, we obtain the quotient equal to 930. So, if you were to divide 9500 meter by 10.23 meter, the quotient will have 4 significant digits. In that case, quotient will be 928.6, because that is a part of the measurement. In any complex multi-step calculation, we retain in intermediate steps one digit more than the significant digit and round off to proper significant figures at the end of the calculation. Like for example, the value of pi, that is equal to 3.141596 is known to be a large number of significant figures. So we can take the approximate value of pi as 3.142 or 3.014 for pi, depending on the significant figures and the most precise measured quantity. Now let us check the rule for addition. In addition or subtraction, the number of decimal places in the result should equal the smallest number of decimal places of terms in the operation. I repeat, in addition or subtraction, the number of decimal places in the result should equal the smallest number of decimal places of terms in the operation. Again, let us take one example. For example, first of all, let us consider for addition. If x is equal to 12.587 meter, y is equal to 12.5 meter, and z is equal to 5.926 meter, then what should be the result? You add it up. So that will give you 31.013. Now this result has to be rounded up to smallest number of decimal places. This means this value. So the smallest number of decimal places, when it is rounded off, that will give you 31.0. So now let us proceed for subtraction. If suppose x is equal to 12.587 and y is equal to 12.5, you subtract, you will get 0.087 meter, which will be rounded off to 0.1 meter, following the same rule. Again, we need to note, in the subtraction of quantities of nearly equal magnitude, accuracy is almost destroyed. For example, for x equal to 12.87 meter, x equal to 12.87 meter, y equal to 12.86 meter, then x minus y, what will be the result? 0.01 meter. The difference has only one significant figure, whereas x and y have 4 significant digits each. To avoid this, we try to measure directly the difference between two nearly equal quantities instead of measuring the quantities and calculating the difference. So I've given you one example where you can see a compiled result of how we can apply the learnt concepts, like the rules regarding multiplication, division, addition and subtraction, and also mixed order of operation. So let me zoom it for you. So in the first case, for multiplication and division, you can see how we can apply the result and how we have rounded it off, keeping in mind the rule. Similarly, for addition and subtraction, and lastly, for the mixed order of operation, we have included all the four. We have included addition, multiplication. See how we have carried out the operation and how we have maintained the rule while writing down the result. Now let us solve one problem to understand it much better. Suppose the given question is 0.9995 into 1.53 divided by 1.592. Suppose this is the result given to you. This is the question given to you. How you are going to solve it? So obviously after multiplying and dividing, I am not getting into the basic calculation part because this is not something that I am trying to stress upon. You can do the calculation by itself. What I really need to show you is how you have to keep in mind the number of significant digits and how you have to round it off. So after doing the calculations, you will get this result 0.96057. But then depending upon the number of significant figures, the result has to be rounded off to have 3 significant digits, because that is the number of digits present in the smallest number. In case of multiplication and division, if you remember, the number of significant figures in the product or in the quotient is the same as the smallest number of significant figures in any of the factors. So in this case it is 1.53, which has got 3 significant figures. So even in our answer there should be 3 significant figures. So for that we need to round off. So on rounding it off, you will get 0.961. So this will be the result for this calculation. Understood? Now we shall proceed with some exercises. Write down the number of significant figures. Let's begin with a very simple question. You are provided with some numbers and you have to write down simply the number of significant figures. The first question, 5238 Newton. How many significant figures does it have? It has 4 significant figures. 4200 kg. Again, 4 significant figures. 34.000 meter. Now since it's a measurement, we have to take into consideration the zeros. So there are 1, 2, 3, 4, 5 significant digits. What about the last one? 0.02340 Newton per meter. So you have to ignore the zeros coming before the decimal point and just the trailing zero. So now 2340. So how many 4 significant figures are there? 4. So very easily we can write down the number of significant figures by looking into the question. The next question, I am reading it for you. The mass of a box measured by a grosser balance is 2.3 kg. 2 gold pieces of masses 20.15 gram and 20.17 gram are added to the box. What is part A, total mass of the box, and part B, the difference in masses of gold pieces to correct significant figures. Now here mass of the box is given. If we assume it to be m, that is equal to 2.3 kg. mass of one gold piece, that is equal to 20.15 gram. We need to convert it into kg, so that will give you 0.02015 gram, sorry, kilogram. Again, mass of other gold piece is 20.17 gram. If we assume it to be M2, and that will be equal to 0.02017 kg. So for the first part, that is total mass, that will be equal to mass of the box plus mass of the gold pieces. So that will be equal to how much? 2.3 plus 0.02015 plus 0.02017 kg, and that will give you 2.34032 kg. So now the result is correct only up to one place of decimal. Therefore, on rounding off, you will get total mass equal to 2.3 kg. For part B, difference in mass, that will be equal to M2 minus M1. So that will be equal to 20.17 minus 20.15 gram, that will be equal to 0.02 gram, and that is correct up to two places of decimal. Let's come to the next question. The length, breadth and thickness of a metal sheet are 4.234 meter, 1.005 meter and 2.01 centimeter respectively. Give the area and volume of the sheet to correct number of significant figures. Let us chalk down the values quickly. Let me create some space. Okay. So we have length equal to 4.234 meter, breadth is 1.005 meter, and thickness is 2.01 centimeter. So this will be 2.01 into 10 to the power minus 2 meter. So area, if I denote it with A, that will be given by 2 into L into B plus B into T plus T into L. This is the formula for area of the sheet. So now we can simply substitute the values. We will get 2 multiplied by 4.234 multiplied by 1.005 plus 1.005 multiplied by 0.0201 plus 0.0201 multiplied by 4.234 2, 3, 4. This we need to calculate. These many square meter. Okay. So that will give us 2 into 4.36044739 square meter, and that will be equal to 8.7209478 square meter. As area can contain a maximum of 3 significant digits, therefore on rounding off we will get area equal to 8.72 square meter. Similarly, for volume will be equal to length into breadth into thickness. That will be equal to 4.234 into 1.005 into 0.0201. So that will be equal to 0.0855289 cubic meter, and on rounding off you will get it as 0.0855 cubic meter, containing 3 significant figures. I'm not getting into the calculations a lot because the stress right now for today's class is on finding out the exact number of significant figures and how we are going to round off. Next question. Subtract 2.5 into 10 to the power 4 from 3.9 into 10 to the power 5 with due regard to significant figures. So let x is equal to 2.5 into 10 to the power 4. That will be equal to 25000, and y is equal to 3.9 into 10 to the power 5. That will be equal to 390000. So y minus x will be equal to 390000 minus 25000. That will be equal to 3636500. So this may be written as 3.65 into 10 to the power 5, and on rounding off to one place of decimal you will get 3.6 into 10 to the power 5. Now coming to the last question. Now this question has been taken from your NCERT textbook. Each side of a cube is measured to be 7.203 meter. What are the total surface area and the volume of the cube to appropriate significant figures? Now the number of significant figures in the measured length is 4. See, it is 7.203 meter. There are 4 significant figures. So the calculated area and the volume should therefore be rounded off to 4 significant figures. So let's begin with the surface area of the cube. So that will be 6 into 7.203 whole square. So that will be giving you 311.299254 square meter, and that will yield the result 311.3 square meter on rounding off. Similarly, for finding volume of the cube, you will get 7.203 cube. That will give you 373.714754 cubic meter, and on rounding off you will get 373.7 cubic meter. So in this manner you can solve a couple of questions based upon the concept of significant figures and rounding off, and the more you practice the better idea you will get regarding the rules that needs to be followed in this context. Thank you.